Good day everyone, you're welcome to my YouTube channel. Today we have an introduction to beta function, and this beta function is defined as beta of n is equal to integral from 0 to 1 x raised to power n minus 1 times 1 minus x raised to power n minus 1 dx. Please, if today is the first time of watching this video, please do well to subscribe to my channel and turn on the notification bell so that you'll be notified whenever we upload new video. Thanks. So now we have some properties here. So we have some properties of this beautiful function. Okay, so we have that nothing changed when we have beta of m and n to be equal to beta of n m. Okay, and we also have this, that beta of m n is equal to integral from 0 to infinity. Okay, x raised to power m minus 1 all over 1 plus x raised to power m plus n dx. We also have beta of m n, that is the trigonometric functions are involved now. 2 times the integral from 0 to pi all over 2. Okay, the sine theta raised to the power 2m minus 1 times the cosine theta raised to the power 2n minus 1, then the theta. Okay, and we have another one. The beta of m n is equal to integral from 0, okay, from 0 to 1 x raised to power m minus 1 plus x raised to power n minus 1 all over 1 plus x raised to power m plus n dx. And we have the relationship between the beta function and the gamma function here. So the beta of mn is the same as the gamma of m times the gamma of n all over the gamma of m plus n. Okay, now we are going to solve some questions. So we're going to use this function. This is a special function to solve the following problem. Okay, so we have the first problem here. We are to evaluate integral from 0 to 1 all over square root of 1 minus x raised to power 2 dx. Okay, now how can we start? Okay, so let us do a substitution by letting this x square equal to k. Okay, so we can see here that x is equal to square root of k, and the x is equal to the k all over 2 square root of k. Okay, so now we're going to substitute in the integral. So we have I equal to integral, the limit remains the same because x squared as x is approaching 0 is 0, x squared as x is approaching 1 is 1. Okay, now 1 all over, okay, square root of 1 minus k times our ds is the k all over 2 square root of k. Okay, so now we're going to write out this 1 all over 2 out. So we have integral from 0 to 1. Now 1 over k can be written as k raised to a negative 1 2, okay, times 1 minus 1 all over square root of 1 minus k can be written as 1 minus k raised to a negative 1 all over 2, okay, dk. Now we are our major priority here is to look for how to manipulate this to look exactly like this before taking this special function. Okay, now let us try rewriting this negative 1 over 2 as 1 over 2 minus 1. Okay, so we have I equal to 1 over 2 integral from 0 to 1 x raised to 1 over 2 minus 1 times 1 minus x raised to 1 over 2 minus 1 dk, I mean k here, so dk. Now we're going to take the beta function from here. So we have 1 over 2 times the beta of, remember, 1 over 2 and 1 over 2 if you compare this to this. So now how do we evaluate the beta of 1 over 2? 1 over 2. So we're using this property here. So now we have I to be equal to 1 over 2 times the gamma of 1 over 2 times the gamma of 1 over 2 all over the gamma of 1 over 2 plus 1 all over 2. So we have this equal to 1 over 2 times the gamma of 1 over 2 square root of I times square root of I. Now here we have 1 over 2 plus 1 over 2 here, which is 1. So the gamma of 1 is 0 factorial, and which is 1. So we have square root of pi times square root of pi is pi all over 2 times 1, and that is 2. So this is the required answer to the problem. So now we're going to the second question we're going to solve using this function. So we have a equal to integral from 0 to pi all over 4 the sine function of 2x, okay, dx. So we're going to start by making some substitution here. So now we can let 2x equal to y. Okay, let's start by saying let 2x equal to y. We know that x is equal to y all over 2, and dx is equal to dy all over 2. Now our new limit, so let's check out our new limit. So we have this equal to integral. Now when x is approaching 0 here, y is approaching 0. When x is approaching pi all over 4 here, so that is 2 times pi all over 4, y is approaching pi all over 2. So now we have sine of y. The x is the y all over 2. So taking 1 over 2 out, so we have integral from 0 to pi all over 2, the sine function of y. Now remember that 1 can be written as cos sine theta raised to the power 0. So cosine theta raised to the power 0. So here we have cosine function of y raised to the power 0 dy. Okay, now this is equal to 1 all over 2 integral from 0 to pi all over 2, okay, the sine function of y times the cosine function of y dy. Okay, now how can we know the actual function we're going to take here? So we're going to take the beta function, but of which values? That is the next question. Now let's go back to this particular place. So before we take this function, we must have a power which will look exactly like this: 2m minus 1 and 2n minus 1. Okay, now the power of y here, the power of this sine function here is 1, and the power of this cosine function here is what? 0, as you can see it. So that is 0. So now this one, we all know 1 can be written as 2 times 1 minus 1, okay, and 0 can be written as 2 times 1 over 2 minus 1. So these are the new powers we have now. So we have a equal to 1 over 2 integral from 0 to pi all over 2, okay, the sine function of y raised to power 2 times 1 minus 1, okay, now times the cosine function of y raised to power 2 times 1 all over 2 minus 1, then dy, and this is equal to 1 all over 4 the beta function of what? 1 and 1 all over 2. Okay, so how did we get this 1 all over 4? Now let's check if this is exactly what this will look exactly like. So we have from here that the beta of mn is twice this integral here. So now when we have this equation, we have 1 over 2 times this integral, and we say that is 1 all over 4 beta of 1 and 1 all over 2. Okay, let's try multiplying both sides by 4. When you multiply both sides by 4, here we have only beta of 1 and 1 over 2. Multiply here by 4, so we have twice this integral. So, and that is correct. So from here we have this equal to 1 all over 4 times the gamma of 1 times the gamma of 1 all over 2 all over the gamma of 1 plus 1 all over 2, and this is equal to 1 all over 4 times, remember gamma of 1 is 0 factorial, which is 1. Gamma of 1 over 2 is square root of pi all over gamma of, remember 1 plus 1 all over 2 here is 3 all over 2. Okay, 1 plus 1 all over 2 here is 3 all over 2, and the gamma of 3 all over 2 is square root of pi all over 2. So we all know that this is simplifying to 1 all over 4 times 2 all over 1. So our a is becoming 1 all over 2. So we said that the integral from 0 to pi all over 4, the sine function of 2x dx is equal to 1 all over 2, and this is the required answer to the question. Okay, now we're going to the final one. So we have this, let's call it b is equal to integral from 0 to infinity, okay, square root of x all over 1 plus x raised by 2 dx. Okay, so this is equal to integral from 0 to infinity, okay, x raised by 1 all over 2, as you can see, then all over 1 plus x squared dx, and this is equal to integral from 0 to infinity x raised by, 1 all over 2 here can be written as 1 all over 2 here can be written as, how can we write this? As a number subtracting 1 from it, so we can rewrite this as 3 all over 2 minus 1, okay, and we have all over 1 plus x, so we need to have exactly 3 all over 2 plus a number here, which will give us this 2 as power here. So let's say 3 over 2 plus 1 all over 2, okay, 3 over 2 plus 1 all over 2, so dx, and we're taking the beta function from here, so we have the beta of 3 all over 2 and the beta of 1 all over 2, and this is equal to the gamma of 3 over 2 times the gamma of 1 all over 2 all over the gamma of 3 over 2 plus 1 all over 2. Okay, now we're going to simplify this, so we have this equal to the gamma of 3 all over 2 is square root of pi all over 2 times the gamma of 1 all over 2 here is square root of pi only, then all over, remember 3 over 2 plus 1 over 2 here is 2, so the gamma of 2 is what? 1 factorial, so that is 1 factorial. So what do we have next? So we have square root of pi over 2 times square root of pi over 1, and this is equal to square root of pi times square root of pi is pi all over 2 times 1, that is 2, and the required answer to the problem is what? Pi all over 2. Now if you know that you enjoy this video so much, just do well to attempt the following problem and make sure you comment the right solution to it, and I will reply you. So we have integral from 0 to pi, okay, the cosine function of x all over 2 dx. Please try this problem and comment the right answer, and I will reply. Please, if you enjoyed this video, please do well to subscribe, turn on the notification bell so that you'll be notified anytime I upload new video. Thank you. Bye bye.